Hi-ho, this is Brendan about to demo downcasting versus abstract techniques such as polymorphism and overrides. So here we have just a demo scene. We're going to use using fruits for this example. So I got here a common fruit BP, as well as some child BPs that derive from fruit for the sake of demonstrating polymorphism in specific, because that is a really powerful version. And we have a fruit manager here to manage the events carried out, spawning, etc. So I just want to basically highlight this graph right here. So as you can see on begin play, we're going to do one of two things depending on how the manager is set up. We're either going to do the downcast way, or we're going to do the polymorphic override way, which is basically the objects overrides themselves determine the final output, whereas downcast, we explicitly as the programmer or developer tell what should happen in each defined type scenario. So as you can see here, the polymorphic flow is very straightforward. A lot of it's implicit, but it's a lot cleaner and much more maintainable and scalable as well. Whereas the downcast flow, right, say I just had to add the watermelon, I would have to go through in this chain and add it to this long casting chain as I try to go through each type. So this can make your class really verbose and extensive. So this is one of the main drawbacks of using downcast and why polymorphism should actually be preferred and a recommended solution. So I'm going to just demonstrate how both work in action to prove that both work equivalent. So here we have some text actors and we have our manager right here that I'm highlighting. If you can see this, I'm going to change the attribute. So this is going to be our basic fruit, and we're going to start off by using the downcast. So the downcast will be in yellow here, polymorphism will be in blue. So here we just have the basic parent fruit with 0 seeds, default values, nothing too fancy there. But now say I switch to watermelon. Then I hit play. As you can see, it basically uses our explicit downcast into watermelon to access the variable seeds on it as well as its title. If I go into watermelon here, you can see it's basically using the title and the seed count variables, and that's what it's just spitting back out if we go into the fruit manager here. So as you can see, it's just getting the seed count and watermelon title. And now you might be asking yourself, well, you seem to be doing that a lot repeatedly. If any of the software developers in the audience remember the dry rule, this is where polymorphism actually comes into play. So what polymorphism is going to do is instead of us having to basically explicitly cast this or convert this, we're going to use the overrides to allow the compiler basically to determine the final output. So what this is going to do is it's going to go through, say, the fruit alert. Watermelon inherits from fruit. Our instance was a watermelon, and so then it will go into watermelon and see its override and then use that instead. And that allows for, context-sensitive actions to happen. So I'm going to show how this can be equivalently done with polymorphism, and if so, will result in you having to deal with a lot less code. So we're going to use watermelon again. We're going to uncheck use downcast to basically use the polymorphic. And look at that. We get the same result. Watermelon, number of seeds, 9,001. We got a little watermelon right there too. So to recap, instead of doing all this chaining to account for every possible type case, and then having to go back and add more should you get more types that you need to account for or, extract from, if everything can be umbrellaed under just a common action or actions, it is recommended to either use a polymorphism to implicitly handle that through leveraging the compiler and overrides, or B, to use interfaces if your classes aren't really connected or related through inheritance. You can just tag on interfaces and implement your final routines through there. just call the interface action and let the objects decide what the result of that action being called upon their interface will be. So yeah, that is basically this short demo. I hope you all enjoyed. Have a good rest of your night.